The European Union has passed the first comprehensive law governing artificial intelligence. Its impact is not contained within European borders. The legislation functions as a strict market filter for AI infrastructure providers worldwide. The law operates on the principle of extraterritoriality. If an AI system's outputs are used within the EU, the provider falls under European jurisdiction, regardless of server location. The penalties reach €35 million, or 7% of global annual revenue. This creates an immediate divide in the tech sector. Some companies will struggle with reactive compliance, while others are already structuring their infrastructure to lead the market. The standard reaction is to treat this legislation as a localized legal checklist, a problem for the compliance team to solve after the engineers have finished development. Strategic infrastructure providers approach it differently. They use the Act's requirements as a framework to build a structural moat against their competitors. They are pursuing a CE mark for AI. It is a verified signal of safety and reliability built directly into the hardware and software layers. Earning this trust premium grants exclusive access to risk-averse enterprise clients and public sector deployments. The engineering challenge lies in taking over 100 pages of legal text and translating them into high-performance architecture without slowing down release cycles. To capture this advantage, regulatory requirements must be engineered into the foundation of the AI pipeline from day one. The first step in building a compliant pipeline is passing the intended AI model through the EU's regulatory filter. The Act classifies AI systems into a 4-tier risk pyramid: minimal, limited, high risk, and unacceptable. Minimal risk applications face almost no new rules, while those at the unacceptable tier are banned. The core engineering burden lies in the high-risk tier. This is where the heaviest operational requirements are triggered. High-risk status applies to AI systems deployed in areas like public infrastructure management, credit evaluation, or automated hiring platforms. A slight miscalculation in how a product is classified dictates the entire compliance workload and liability profile for the infrastructure provider. Building a compliant high-risk AI architecture starts at the beginning of the pipeline: data ingestion. The law mandates strict data governance. Training data must be highly relevant, statistically representative, and scrubbed of errors to mitigate bias. At the training layer, the system requires exhaustive technical documentation. Engineers must maintain records explaining the model's architectural design and its exact intended purpose. Finally, at the deployment layer, the infrastructure must include automated logging to ensure complete lifecycle traceability, recording events and decisions the AI makes in real time. Installing these technical modules transforms an opaque model into a transparent, legally auditable asset. Code is only half the architecture. Post-deployment, the infrastructure requires ongoing human and operational management. The system must include hard-coded human oversight failsafes. Operators need the physical ability to intervene, override, or shut down the AI if it behaves unexpectedly. To monitor these safeguards, providers must implement a quality management system, or QMS, a set of formalized processes for continuous compliance and risk management. This chart shows the estimated financial reality. Implementing the Act's key mandates adds roughly €29,000 in annual labor costs per high-risk AI system. Across the industry, total global compliance spending is projected between €1.6 and €3.3 billion. Laggards will absorb these costs as a hit to their profit margins. Industry leaders will automate their quality management systems to handle the workload efficiently. Operational efficiency in compliance creates a pricing advantage over competitors reliant on manual processes. There is a parallel regulatory track that many developers overlook: the rules governing general-purpose AI, or foundation models. Even if a foundational model isn't designed for a specific high-risk application, it is still subject to these requirements. All general-purpose AI providers must meet baseline duties regarding transparency. They are required to detail their training data and ensure their datasets comply with European copyright law. This graph illustrates how the regulation treats scale. The horizontal axis tracks raw compute power, measured in flops, floating point operations per second. The vertical axis tracks regulatory risk. When a model is trained using more than 10 to the power of 25 flops, it crosses a computational threshold that activates the systemic risk classification. This trigger forces infrastructure hosts to implement mandatory red team testing to simulate misuse scenarios, alongside protocols to mitigate systemic risks. Raw compute power is now a direct, measurable regulatory liability for hyperscalers and infrastructure providers. Compliance is not a launch day checklist. The Act mandates proactive tracking long after the model goes live. Providers must establish post-market monitoring systems and report any serious incidents or malfunctions to authorities within tight deadlines. Think of this telemetry like pharmaceutical safety protocols. The network detects and isolates digital anomalies before they lead to public disasters. Strategic companies view this monitoring as an extension of premium customer service, continuously refining their product based on real-world feedback. Investing in robustness and telemetry today acts as reputational armor against future AI anomalies. Zooming out, a fully compliant, architecturally sound model integrates seamlessly with secure enterprise systems like banks and government servers. Meanwhile, non-compliant models are blocked by procurement firewalls and risk-averse legal teams. This dynamic is accelerating the Brussels effect, the phenomenon where European regulations become the de facto global standard for AI governance. The organizations that adapt gain three distinct advantages: exclusive market access, true operational excellence, and deep risk resilience. The regulation has drawn a hard line. Organizations that engineer their way across it first will define the future of artificial intelligence.